In this video, I will explain how to find the optimal consumption bundle for a consumer given a utility function and a budget constraint. So let's jump right into an example. This says Sam's preferences for two goods, x and y, can be expressed by the function u equals xy squared. Assume Sam has an income of $400. The price of good x is $10 and the price of good y is $20. Find Sam's optimal consumption bundle. So we're given a utility function. This shows the utility that Sam gets by consuming goods x and y. The question that we're posed with is, given that Sam has an income of $400 and given the price of good x and good y, how much of good x and good y should he consume to maximize his utility? So to figure this out, there are two important things that we need to know. The first is that the optimal consumption bundle for Sam is going to use all of his income. So for him to maximize his utility, he's going to spend all of his income. In this case, he's going to spend all of the $400. And the other thing we need to know is that the optimal consumption bundle occurs where the indifference curve and the budget line have the same slope. Now, the slope of the indifference curve, that's equal to the marginal rate of substitution. And the marginal rate of substitution is equal to the marginal utility of good x divided by the marginal utility of good y. And we take the negative value of this. And the slope of the budget line is simply the ratio of the price of good x to the price of good y. And we take the negative of that as well. So all we have to do is find these two values and then set them equal to each other. So first let's find the marginal utility of x. So I'll write that over here. The marginal utility of x. When we're given a utility function like this, the marginal utility of x is the derivative of the utility function with respect to x. So the derivative of this utility function with respect to x, all we're doing here is we're taking the derivative of x, which is just 1. And then we also have to include this y squared. So really, it's just y squared. And then we can find the marginal utility of y, which is simply the derivative of the utility function with respect to y. And that would be, we take the derivative of y squared, which would just be 2y, and then we also keep the x. So we'll have 2xy. Now the marginal rate of substitution is simply going to be the ratio of these two values. So let's write the marginal rate of substitution is equal to, and don't forget we have a negative sign out front. So we have the negative y squared divided by 2xy. So we can simplify a little bit. We can cancel out this y with one of these y's, and we end up with negative y over 2x. So this is our marginal rate of substitution. Now we can also find the slope of the budget line, which remember is just this formula right here. So that would just be negative, the price of good x is $10, so we'll say 10, divided by the price of good y, that's $20. So we'll say 20. So that simplifies to negative 1/2. So Sam's optimal consumption bundle will occur when these two ratios are equal to each other. So here's what we can do. We can set them equal to each other and say negative y divided by 2x must be equal to negative 1/2. Now since there's a negative sign on each side of this equation, we can cancel those out, and then we can cross multiply and set these two values equal to each other. So we get y times 2, let's write that right here, that's 2y, is equal to 2x times 1, so that's just 2x. And then lastly, we can cancel out the 2's on each side, and we'll see that y is equal to x. So what this tells us is that the quantity consumed of y will be exactly equal to the quantity consumed of x. Now the last step, so to figure out what these quantities actually are, is we need to write the equation for the budget constraint. So I'm going to clear a little bit of room here and write that equation. Okay, so we found that y is equal to x. Now we just need to write the equation of the budget constraint, which takes this form. M, which is our total income, is equal to the price of good x times the quantity of x plus the price of good y times the quantity of y. So to write this budget constraint, we can fill in the values that we know. Our income is 400, so we can say 400 is equal to the price of x, we said is $10, so we'll say 10 times x, remember this is the quantity, this is what we're trying to figure out, plus we have the price of y, so that's $20 times the quantity of y. Now we figured out that y must be equal to x. So what we can do is for y in our equation right here, we can just plug in x because we know y is equal to x. So let's go ahead and plug that in. So we get 400 is equal to 10x plus 20, and we'll plug in an x right here for y. So we have 10x plus 20x, that's 30x. So we have 400 is equal to 30x If we divide both sides by 30, we'll find that x is equal to, these 30s cancel out, so we have x is equal to 400 divided by 30. That turns out to be 13 and 1/3. So the quantity of good x that we're going to consume is 13 and 1/3 units. And remember, we found that the quantity of y will be equal to the quantity of x. So that must mean that we're also going to consume 13 and 1/3 units of good y. So Sam's optimal consumption bundle would involve consuming 13 and 1/3 units of good x and 13 and 1/3 units of good y. And we'll find that when he does this, he uses up all $400 of his income and he maximizes his utility.